For one of the things in organic that the book had them do was to be able to differentiate between an endothermic and exothermic energy graph. So I'm going to go ahead and add that to Chem 2 as well. And so if we had an energy graph, which is what we've got here, I'm going to do an exo. So energy, it would be on the Y in kilojoules. And this would be just time on the x-axis in whatever unit. And then we're going to look like what an endothermic would look like, because you're going to need this for organic, so we might as well, these are super easy. Super easy. Let's see what a graph would look like in kilojoules. I don't have a unit on my time because it depends on the reactions. Could be seconds, could be minutes, could be days. So all of them, all things start out with a certain amount of energy. Could be down here, but we start with energy at some spot. I'll just start with the spot. So where we start is the energy of your reactants. So right here are your reactants. I'm just going to put R on this side. Okay. And then everything requires a certain amount of energy to get started. That's called activation energy. Activation energy is the minimum amount of energy it takes to start a reaction. Oh, don't know what my board's doing. That is the minimum amount of energy. Minimum, that's supposed to be minimum amount of energy required to start a reaction. Minimum amount of energy required to start a reaction. So on a graph, that's when it's going to start climbing upwards. So some of them are really tall and some of them may be short. It just depends on the reaction. I'll make these two about the same. Okay, so if it's an exothermic reaction, we actually end up lower than we started. So we have reactants here and then we have products here. Goodness gracious, that's supposed to be a C. Doesn't look like a C. So you've got this climb, but notice the product is down lower. If it were an endothermic, you still have reactants, you still have activation energy, but it ends up higher. This is our product. So if I do product minus reactants, big number minus little number, I'm going to get a positive H here. So it's the difference between them. Same with this. Products minus reactants, I'm going to get a negative H here because it'd be a lower number minus a higher number. So let me get a, so this little area right in here. Oh, I didn't do it very well. That little thing that I just made pink is the activation energy. We usually write this E with a little a, E sub A. This is E sub A, E sub A. That's the amount. So I could figure out how much activation energy by taking where it was here to the very top of that, called the activated complex here. Those are just some terms and some graphs that you're going to see in organic, and so I think I might put one of those on your test just where you could see knowing the difference between an endothermic and exothermic. So if it ends lower, it's an exo because it has given away some of its energy, and if it ends up higher, it has absorbed energy, so it's an endothermic reaction. But it does tie in that positive delta H, etc. Alright, so moving back to the notes, I decided I just needed to add that because I was sitting through the organic class last fall and noticed that those graphs were in the book and some questions were over that, and I felt like I needed to probably review that.